Alright, it seems we're live, and in this series of videos I'm going to be doing live C programming and showing you the solutions that I think are good solutions for typical problems that one encounters when doing embedded programming in C. I'm going to be implementing device drivers, I'm going to be debugging, and I'm going to be working on my motor controller board, which I've been broadcasting live. I've been broadcasting the design of this board live from the beginning, from the block diagram to PCB design to soldering, and now we're going to be programming this board. So next on the list, or actually, I'm gonna just go over some of the changes that I did to the console. I've modified my console driver such that it's now plugged into the more generic driver framework that I have in my firmware. And let's see, we're in terminal mode, so we need to exit terminal mode. Let me just check, make sure that the live stream is still streaming. Good. Let's see. I've modified the driver to be a generic console driver that plugs into the generic interface, which then exposes an API through which other drivers can add console commands. And the first command that I've added, my dog is like, no, you're not going to be coding any C code, you're going to be playing with me now. And I'm like, no way. Not right now. And my dog goes like, no, that's not going to work. I'm going to make sure that you play with me. I'm going to use every single tool that I have in my repertoire to make sure that you play with me. So we're going to have to do it like this. I'm going to get a toy, and I'm going to be throwing the toy I'm going to be throwing the toy, and she's going to be getting the toy, and then while she does that, I'm going to be trying to get some work done. Let's see. Where are the toys? Sit. Come. Draw. Sit. Draw. Okay, let's see if this is going to work. So basically I've added a new subsystem to the firmware, which is implemented using the same concept that I use for other subsystems. But in this case, it's a console subsystem, which exposes generic interface for the console, implemented by console ops. And right now there's just one method, add command. And then there is a few utility methods for registering console devices and finding console devices. So any driver can now find a console device based on device tree node. So this allows us to implement or to define the console based on the device tree. And we have our device tree here, and we can then define our console like this. So we have a console node, and this console node binds to the console driver, which in this case is our generic console driver, and then it also has a parameter which specifies the serial port on which the console is going to be running. So we can instantiate as many consoles as we want, and we bind them like this through the device tree, so no changes to the code are necessary. I've started using device tree in my firmware I think about a year, maybe a year and a half ago, and I absolutely love the concept. I think it simplifies so many things, and even though it's a little bit more boilerplate to write for each driver, the net result is very flexible, and drivers don't depend on other drivers explicitly. They only depend through the device tree. And because the device tree is specific for each board, it essentially is totally fine to have the dependencies in the device tree, and in fact that's where they're supposed to be. They're not supposed to be in the code anywhere. So gradually I'm moving a lot of the code to the device tree, and adding this extreme amount of flexibility to how we can connect things together. So here we create the console driver, or the console device, and then down here we create, we define a command which is implemented by our CPU driver, which in this case would be the CPU info command. And this in turn then points to our console. So we can do things like this now. If we go to our CPU info, let's see, CPU, let's see, so I'm going to open this file, and then we have the CPU info driver defined here. So we have first the device driver for the CPU, and then we have this a little device driver that just implements the console command. And it's defined the same way as any other device driver, but in the probe method, it retrieves our console from the device tree, and then it registers the CPU info command. And in this case, the CPU info command is very specific to the specific CPU. So we essentially want to have this implemented in the chip-specific code, which has access to chip-specific headers and chip-specific APIs and addresses, things like that. So doing it like this allows us to essentially limit the scope of this driver to just the lowest level APIs, and prevent any other code from explicitly depending on this particular implementation, which in this case is for STM32. So I've added this command, and I haven't implemented the method yet, but I think I will write a small CPU info method. Essentially what I want to do is just move the code that prints the frequency of the clocks, maybe the serial number of the CPU, and possibly some other details. We can actually do like this, RGC get clocks. Let me just check what we can do. So I think I had some print K here somewhere. Let's see. I just realized I happened to remove the autocomplete plugin, which was not intentional. But let's see. I think it's get clock status. No. RCC get clocks. Can we look? I have to re-add that plugin. That was a very good plugin. I'm gonna go to viewer. RCC get clock fracs. Yeah. Get clock frac. Clock frac. Clock status. Actually, I'm gonna re-add this plugin. Let's see if we can re-add it without restarting the program. Config. We have the plugins here. So could it be this one? Nej, hämta. Kom, hämta. Loss. and plugs install. Did I get the completion working? Now I'll have to restart the program. Anyway, we can do like this. Nein, komm hier. So, sit. 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 Ja. For some reason, my bindings to the code base have disappeared. I don't know why it's not working. I cannot navigate the code by using shortcuts, so I can't just go to definitions and stuff like that. For some reason, it's not working right now. I'll have to investigate that later and possibly restart the program. Let me just do it like this. Come. Usually I can just use shortcuts to jump to definitions, which is very practical. For example, I would just jump like this, but right now it's not found. So for some reason it's not working. So I'll have to just go the hard way. Let's print out the clocks. Or actually, so this is just I'm in the process of implementing this console API, and I have this method that implements the command. It actually gets the console as a parameter. So it would be nice if we could print to a specific console instead of using print k, because print k is going to print to the default console. We don't want that. We want to print to a specific console. For example, if we have a console attached to a UART, we want to send a response to that console and not into the default console. So it would be nice if we could implement that method, and that's something I can have a look at in a bit. So let's see. We have the console, and we have the API here. So we can close. I wonder if I can just use like this printf console. This will accept the console device and const char format and a bunch of arguments. And we already have this the implementation of this method in the console router. It's just not bound to this abstract function. So this is like a way of implementing the virtual methods in C, and it's pretty simple. It doesn't require much extra code, but it's a little bit different from how you would do it in C++. You essentially define a struct with your methods, and then you have methods that accept a pointer to the abstract interface. And from that you can retrieve, using container of, you can retrieve the pointer to the actual implementation object for this device driver. So I'm going to go to console C, and I'm going to find this method where I'm, let's see, actually I need to save this. So let's see. I have a method that prints out, implements the printf somewhere. So things like reboot, this will essentially go to the CPU driver. So a lot of this, a lot of these functions that depend on that currently make the console driver depend on implementation-specific code will essentially disappear and be moved to other drivers where they rightfully belong. So we got conprintf here. This can be int, and this will accept our console pointer. Oh, now it's actually working. So it seems that it worked for new buffers. Let's see, dev, and then we have, instead of the serial, we will actually get the self pointer. So struct console self would be container of, and then dev, and then it's going to be, because we have so it's going to be struct console and dev ops, because this pointer, the interface is actually a pointer to the ops variable inside the dev object, and dev object in this case is the generic console object. Let's see, so we don't need that, we just go like this, and this will be our return value. So we can return this, let's see, otherwise return R. This is the old implementation, so I'll remove that. Let's see. And this will be static because it shouldn't be visible outside of this file. And then I will add the pointer here as well. Let's see. So we have console ops, and we have the ops here, and this will be printf equals console printf, and this will be console printf. Okay, just one more thing. I need to add a little macro for to simplify the call to this generic function. And this will be printf, and this will be format, and then a bunch of arguments. And then we want to just paste the arguments onto this, let's see, so we'll have VA args here. So this should paste the arguments and send them to that function. Okay, so now we should be able to use conprintf, and we should be able to do it from the driver as well. Let's see. So now in this method here, we can just do conprintf, let's see, hclock, we have pclock 1, pclock 2. And then we have, I think, sysclock. Actually, I'm going to play sysclock first. This will be clocks. let's flash this. And we have RCC not defined, so we need to add this. Or actually, it should be defined. Let's see. Did I define that wrong? RCC clocks status. Actually, I think it's called like type def. I think the name of the RCC clocks type def. So that's what it needs to be called. Get clock status also. So there was a method get clocks frick. Oh, right, I see. Yeah, so the error was actually not passing the right function, the right argument there. Let's see, so... so why is it complaining? Let's see, what does it say? Argument. Oh, I see. So this is something. There is some definition that essentially. Let's see. Yeah, those clock. Yeah, I missed an S there. That's why. So there is some definition somewhere that defines clock. So we have conf printf. Right, of course. This. It's complaining about the args. Come. Hey. Come. Right, and we have the reboot here. So I think I will actually move this method to the CPU driver as well. Probably call this driver like CPU commands or something. add this command as well. Remove self, and we can so I need to fix that. Console. And this needs to include the chip interface. Right. So yeah, there is one little detail about using the VA args in this manner. So it's important to make sure that VA args also includes the format, so that if there are because format is always required, so we can do like that. And instead of self, this will be con. I think that there is another way of specifying variable arguments, which doesn't require at least one argument. I think it's probably the VA args without the star or the square character. And we have also the set command, which also uses the conprintf. So this is my default implementation of generic variables, where different drivers can define different variables that can be set from the console, which is very useful. But I haven't ported this to my new driver API yet. So I think I will just, for now, I'll just comment this out. This is not very important for this application right now. Let's see if we get any other errors. At the console task. Okay. So we can just do like this, console printf, and this will point to the ops. Or it doesn't actually matter because, yeah, I can do it like this. This is okay because this is all defined in the same file. So I can just call the interface method directly. We got the read line, and I think this could be, we have help there as well. cmd help, cmd reboot. So this goes away. This is not necessary anymore. And where is cmd help? Did I also remove cmd help? Oh, I commented it out. This is weird. This needs to be placed here. There is something missing. I think there is. Usually, this kind of error occurs when there is some syntax error somewhere. So let's see if we can. It's actually this one. So this needs to go after the end of. Let's see. Yeah, now we got another printf. Console. And then we have, this would be pointer to DevOps. And the same thing here. Another one. What is the option for GCC to make sure that it prints all of them? Yeah. Let's see. This one is not powered, so I'm going to power the board. And I'm going to try to flash. It's written. Let's see if this works. CPU info is not created, which is quite obvious why. I forgot one thing. I can eventually simplify this code so that I don't have to write several copies of it. Now it works. Great. And reboot. And reboot works too. Awesome. Okay, this video unfortunately became a little bit long before I actually would have started the work on implementing the drivers for the shift registers. So what I'm going to do is I'm going to stop this video and I'm going to start a new recording for implementation of the drivers for the shift registers. And these drivers will drive the chips that are located here on the board. So these two chips, they connect to debounced button inputs, and they also control some of the control signals on other chips. So they're important to get working right now. Before moving on to the other devices which require the functionality of the chips. So that's it for this video. I hope you learned something, and see you next time.